Hello and welcome to Lapping Analytics. Are you dealing with small or large samples of qualitative and quantitative data and interested in how combinations of observed or coded conditions contribute to an outcome of interest? My name is Jimmy Lapping, and in this video I present an example of qualitative comparative analysis, a configurational approach that integrates key strengths of qualitative and quantitative research in a mixed methods fashion. Suppose we are interested in finding out more about specific factors that help to quit smoking. We may consider a new or already established health intervention. We may want to investigate to what extent people having a habit of exercising tend to quit smoking compared to people who do not exercise. And another fact of interest may be a person's alcohol consumption, in the sense that lower levels of alcohol intake might be associated with an increased likelihood of a person smoking. Each of these factors, health intervention, a habit of exercise, and a relatively low alcohol intake, may help to quit smoking to some extent. And when combined, the likelihood of a person quitting smoking goes up further. That's the idea behind the study. So, the outcome of interest in this example study is quit smoking. Let's say the health intervention is a type of professional coaching. Exercise in this study is defined as having a routine of at least 1 day a week of exercise, either going to the gym or running or some other outdoor activity that can be classified as exercise. And a low alcohol consumption is defined as 1 or 2 glasses of alcohol on weekend days and bank holidays, and no habit of alcohol intake during working days, weekdays, let's say. And although the study may focus above all on the contribution of the health intervention to the desired outcome, exercise, alcohol intake, and the combined occurrence of 2 or 3 of these factors are also examined in order to get a deeper understanding of conditions and combinations thereof under which quitting smoking is more likely. Suppose we have only access to 16 people who have communicated that they would like to quit smoking. Of these 16 people, there are 8 who exercise and 4 who have alcohol intake levels higher than what would be classified as low alcohol intake. These 16 people are divided randomly over either a health intervention condition or a control condition, such that each condition has 8 people, of whom 4 exercise and 2 have relatively high levels of alcohol intake. This way, both the health intervention condition and the control condition, in which no intervention takes place, have the same proportions of people exercising and also the same proportion of people of relatively high alcohol intake. The outcome of this study, measured 6 weeks after the participants were contacted for the study, is either 0, meaning still smoking, or 1, meaning quit smoking. Hence, the 8 cases marked yellow are people who quit smoking. And given that the cases marked brown are the ones who had the health intervention, in this study professional coaching, we can see that 7 out of the 8 people who quit smoking had the intervention, and only 1 participant who had the health intervention did not quit smoking. Next, the cases marked green are the ones who have a habit of exercising, and just over half of them quit smoking. And finally, of the 4 relatively heavy drinkers, only 1 stopped smoking. So how can we analyze this data set in order to find out how these factors, health intervention, exercise, and alcohol consumption, contribute to the desired outcome? Some people may propose logistic regression, After all, the outcome variable is dichotomous, and we are interested in how three different factors contribute to the desired outcome of that dichotomous variable, in this case, quit smoking. However, with only 16 cases, there is no way we can run a logistic regression with these three contributing factors, or even two of them, and expect meaningful outcomes. If we had 100 cases or more, things would be different, but here we only have a sample of 16. So what then? Go variable by variable? For example, since the intervention is the first factor of interest, simply look at the distribution of quitting or not quitting smoking in the intervention and control condition, and that's it. While doing so, we can calculate a range of statistics, including the so-called percentage of all non-overlapping data, or band, which is 0.875. If you're interested in this kind of statistics, I have several videos on this matter on this channel, but the problem is that such variable by variable statistics do not tell us anything about combined contributions of different factors, which happens to be of interest in our study. So this is where qualitative comparative analysis comes in. When non-dichotomous variables are concerned, we can perform a so-called fuzzy set qualitative comparative analysis, FSQCA, on which I will show examples in future videos on my channel. And when we deal with dichotomous variables, we speak of crisp set qualitative comparative analysis, which happens to be the case in the study at hand. Now, there are several programs to perform such analysis, including the freely available FSQCA program that you can find via the link here, and I also used for the dataset at hand. And when we use that program to analyze the data at hand, we get different kinds of output, including a table in which each condition and each combination of conditions is analyzed in terms of consistency and coverage. Now, instead of providing mathematical formulas, which can also be found in the freely available manual of the program, I'm going to explain and discuss consistency and coverage with actual numbers. To start, we see that the health intervention condition is given a consistency score and coverage score of 0.875. What do these numbers mean? To start, both consistency and coverage can range from 0 to 1. The question we ask ourselves for the consistency of EXP, which represents the health intervention condition, is what proportion of the people who took the intervention quit smoking. In this case, 8 people took the intervention and 7 of them quit smoking, hence 0.875. Next, coverage is about the question what proportion of the people who quit smoking had the intervention. In this case, 8 people quit smoking and 7 of them had the intervention, hence 0.875. Next, for exercise, we find somewhat lower numbers because only 5 of the people who exercise quit smoking, and of the 8 people who quit smoking, 5 people exercise. Now, if you think that coverage and consistency always lead to the same outcome, you are mistaken. This has been coincidence, as the following example shows. Here, alcohol is reverse coded because our expectation is that a lower alcohol intake increases the likelihood that a person quits smoking. So there are 12 people who were classified as having a low alcohol intake, and of those 12, 7 quit smoking. Hence, a consistency of 0.583. However, the coverage score is higher because of the 8 people who quit smoking, 7 have a low alcohol intake. Next, the combined occurrence of health intervention and exercise. There are 4 people who exercise and took the health intervention, and all 4 of them quit smoking. Hence a perfect consistency, 1. However, there are also 4 people who quit smoking without that combination. In other words, the combination of exercise and health intervention only explains or covers 4 of the 8 cases who quit smoking, hence a coverage of only 50% or 0.5. In other words, while in this sample the combined occurrence of health intervention and exercise always led to the desired outcome, that is, quit smoking, it only covers half of the cases. Next, the combined occurrence of health intervention and low alcohol intake. There are 6 people in this sample who have this combination of conditions, and all 6 of them quit smoking. Hence, for this combination, we find a perfect consistency as well. However, of the 8 people who quit smoking, only 1 did not take the health intervention, and instead was in the control condition, and another participant had a relatively high alcohol intake. So these 2 cases had showed the desired outcome without this specific combination of health intervention and low alcohol intake. In other words, both the combination of health intervention and exercise and that of the health intervention and low alcohol intake constitute sufficient conditions for people to quit smoking, consistency of 1, but not necessary conditions since the coverage is far from perfect. Next, the combined occurrence of exercise and a low alcohol intake. Of this combination, we find 3 participants in the control group and 4 in the intervention group. And of these in total 7 people, only 5 quit smoking. Hence a consistency of 71.4% or 0.714. And since out of the 8 people who quit smoking, 5 have the combination of exercise and a low alcohol intake, the coverage is 0.625. And finally, the combined occurrence of health intervention, exercise, and a low alcohol intake, in other words, all else equal, expectedly the relatively healthier subgroup, is observed in 4 cases, all of whom quit smoking. Hence perfect consistency. Yet these 4 cases that have this extensive combination only account for half of the cases who quit smoking, hence a coverage of 50% or 0.5. So if we have to choose a single factor that is either health intervention or exercise or a low alcohol intake, the health intervention wins. Consistency values closer to 1 are desirable because it means there are fewer exceptions to the rule. And consistency values below 0.75 or even below 0.8 are generally not considered sufficient. However, the FSQCA program will propose the combined occurrence of health intervention and a low alcohol intake as the preferred solution for this dataset, because this solution is, at least in this small sample, perfectly consistent, hence no exceptions to the rule, and has a considerably better coverage than the 2 alternatives that have a perfect consistency. Of course, it should be noted that causal interpretations for exercise and alcohol intake are more questionable than for the health intervention, since the latter we managed to randomize, and that the results of a convenience sample, as the 16 people who happened to be available, contactable, the results of a convenience sample are not necessarily generalizable or transferable to other settings. But well, this is where replication studies and ultimately systematic review studies over series of studies on the same phenomenon come in. There is much more to say about guidelines for this kind of analysis, and if you want a freely available tutorial article on this matter, then I recommend this one, which was published a few years ago in the International Journal of Information Management. And in future videos, I will also discuss examples of fuzzy set qualitative comparative analysis, since many phenomena in the behavioral sciences cannot be reduced to simple dichotomies. But I hope you find this video useful. If you have any comments or questions, suggestions, just leave a comment below this video. And on my channel, you will find plenty more videos related to methods for qualitative, quantitative, and mixed methods research. Having said, thank you for watching, thank you for listening, and I hope to see you soon.